Okay, good day. This is Dual Enrollment Pre-Calculus. I am Mr. McCulley, and this is lesson number 19, Trigonometry of Any Angle. Let's get right to it. Today, we are going to be learning how to evaluate trigonometric functions of any angle. We're going to use reference angles to evaluate trigonometric functions, and we're going to evaluate trigonometric functions for any real number. So let's review back what we were using. We were using the unit circle, and in each case, the unit circle, our hypotenuse of the special right triangles was a value of 1. That's not always going to be the case. So let's say I have some angle theta here with some length right here to some point x and y. Now, if this length here, which I'm calling r in this particular instance, is not 1, then the sine of theta is no longer just y, it's the sine of theta is y over r. Now, r is, and again, if you notice that this looks very much like the Pythagorean theorem, that's because it is. Our r is the square root of the sum of the squares of both the x and the y value. If that ends up being the case, then y over r is going to be our sine value, x over r is going to be our cosine value, and y over x will be the tangent value, the cosecant, the secant, and the cotangent being the reciprocal of its corresponding trigonometric function. All right, so let's talk about reference angles. And so we're defining some reference angles here. If theta is in any angle in the standards position, then its reference angle is an acute angle theta prime formed by the terminal side of theta and the horizontal x-axis. All right, so what does this mean? Well, let's say I open a theta of 3 pi over 4. And that is 3 pi over 4. Find its reference angle theta prime. Okay, so it says formed by the terminal side of theta and the horizontal x-axis. So my reference angle, theta prime, will be the terminal side. So right there's the terminal side and the horizontal x-axis. So this angle right here is going to be theta prime. Now, it just depends on where your terminal side is on how you calculate that. In this particular instance, this angle, because we're at, we've gone halfway around, is going to be pi minus 3 pi over 4. So our theta prime in this particular instance is going to be pi minus the 3 pi over 4. Now, if I need to figure that out, remember we need a common denominator. So this is 1 pi. So there are 4 pi over 4. So there's 4/4 of a pi in 1. Minus 3 pi over 4 gives me just pi over 4. And that is my reference angle. Now that reference angle is always going to be somewhere in this first quadrant. So just as another quick example, let's say as a for instance, I had another one. Let's change this up just a little bit. Make it another line here. Let's make it green. And so let's say I did this angle right here and we came around with a red line. Make that a little smaller. We came around to here and we said that this was let's say we said theta was 5 pi over 3. Yeah, it's that value right there. What is the reference angle? Well, this reference angle, theta prime, will be the angle, the acute angle from the terminal side. In this case, it's this green side, and the horizontal x-axis. So this angle right here is now the theta prime. And so in that particular instance, it's going to be theta prime equaling to 2 pi minus 5 pi over 3. And 2 pi in turn, there are 2 in 2, there are 6/3. So 6 pi over 3, 6 divided by 3 gives me the 2. Minus 5 pi over 3 gives me just pi over 3. That's my theta prime. And again, you're going to have to make the situation work for which quadrant you're angle lies in. All right. So this slide I have as the unit circle just in case we need it, but let's get on to some other examples. If I have determined the exact value of the 6 trigonometric functions of the angle theta, and so in this particular instance, my theta is actually even bigger than a straight angle, excuse me. And so we're talking this theta here. Now, if I think about it in terms of a right triangle, this side right here is going to be the -5. This side right here is going to be the 12. Well, the good news is that here's a right angle, and again, this is my theta, but this 5 is still going to be the opposite side, and this 12 is still going to be the adjacent side. What I don't know is the hypotenuse. So I'm going to put a little h right there. Actually, to use the same expression, we're going to use r. So I'm going to use an r right there, and I can say that -5 squared plus 12 squared is equal to r squared, and so I get 25 plus 144 equal to r squared, and so r squared equals to 169. When I add those together, take the square root of both sides, and again, we would say plus or minus, but this is a length, and so it's definitely the positive value, 13. So r equal to 13 there. So if I got to find the exact value of the 6 trig functions, I'm going to set it up just like we've been setting up the last couple. Let's say sine theta, cosine theta, tangent theta. I'm going to say cosecant theta, secant theta, and cotangent theta. I'll put my equals right here. And so sine, opposite over hypotenuse. So -5 over 13. Cosine, adjacent over hypotenuse. So 12 over 13. Tangent, opposite over adjacent, -5 over 12, and then cosecant, secant, and cotangent are just the reciprocals. Should be a 13, we can make it a 5, and then 13 over 12, and then -12 over 5. So there we go, and done. Next example, maybe, if it goes to the next slide. Please go to the next slide. Oh, it's not responding. Okay. State the quadrant in which theta lies if we have this expression. Okay, so let's talk about this. All right, here is my, oops, I want black. Let's go, oops, here. There we go. I want black. All right, so we have quadrants. We have the first quadrant, second quadrant, third quadrant, and the fourth quadrant. And so what quadrant does it lie if the secant is greater than 0? Okay, so secant's greater than 0, that means 1 over cosine theta is greater than 0. Okay, well, if cosine is greater than 0, then, or 1 over cosine is greater than 0, then the cosine has to be positive. So I get positive divided by positive. So cosine is positive. The x values are positive in the first and fourth quadrants. So if let's just kind of shade that in with a highlighter here. So secant theta is greater than 0 where we shaded yellow. Okay, that's no problem. Cotangent is negative. All right, so cotangent, let's see, what was cotangent? I have cosine, or let's do it this way. The cotangent of theta is equal to cosine, oh, doing awful. Let's do a better job. Cosine theta over sine theta, and that still has to be less than 0. So what has to be true for a value to be less than, for a fraction to be less than 0? Well, either the numerator or the denominator has to be negative, but not both. All right. So in quadrant 3, they're both negative, which would be negative divided by negative is positive, so it wouldn't be less than 0. In the first quadrant, it wouldn't be 0 because we'd have positive divided by a positive. But in the second quadrant, the y value is negative, or is positive, but the x value is negative, so it would work in this particular quadrant. All right, And in the fourth quadrant, the x values are positive, so the cosine would be positive, and the sine is negative. So positive divided by negative is going to be a negative, so the place where they overlap is where both of these things are true. So my final answer for this particular one is obviously the fourth quadrant. Box around that, move on. Okay, find the reference angle for the special given angle. So I'm looking for reference angles for these two. And so I'm just going to draw myself a little picture here so that I can have a little bit of a reference. Okay, so 315 degrees. If I start at the standard position and I go around, there's 180, 270, 315 would be right there. So we're opening all the way around to this value there at 315 degrees, not 350 there, McCully. 315 degrees. Okay, so the reference angle is going to be this terminal side to the x-axis, so from right there. So all the way around would be 360 degrees. So 360 minus 315 is going to be 45 degrees. That's my theta prime right there. Okay, so let's erase this. Let's use the same picture here. And this is just way too big. So let's make this much smaller. There we go. That's a little bit nicer. All right, so negative 5 pi over 3. Okay, so we can do that. So I start here. There's negative 1 pi over 3. 2 pi over 3. 3 pi over 3 is 180 degrees. 4 pi over 3, 5 pi over 3. So I start here and I go negative to there. Now, again, my reference angle, my theta prime, is going to be the distance between the terminal side directly to the x-axis. Now, I know it has to be this one. It can't be that. It can't be from here to here because that would make it a obtuse angle, and they want the acute angle, so the smallest one possible. So if there's 5 pi over 3 to get all the way around to 2 pi, that would be 6 pi over 3. We are 1 pi over 3 away, so that's our answer. And we are finished with that one. Last one of the day, it says give two solutions for the given equation. So we're trying to figure out theta. We are solving for theta. So it says there's two solutions. All right, so I need two values, two angle measures, and it doesn't say which one, but we'll do radians. We'll put in radians. Give me two angle measures that'll give me a cosine of square root of 2 over 2. So cosine are the x values. So go back to this unit circle, maybe, hopefully. Come on, go back to the unit circle. Not responding again. That's not giving me a whole lot of... There we go. All right. So I'm looking for x values of square root of 2 over 2. So I have an x value of square root of 2 over 2 here, and I have an x value of square root of 2 over 2 here. So I need the angles that produce that. So my answer is 7 pi over 4, or pi over 4 and 7 pi over 4. So I'm going to come back down here. Theta equals 2 pi over 4 and 7 pi over 4. Well, that's all I got. So today's Super Fabu Star Wars Fun Fact of the Day. And the original script for New Hope was focused on General Star Killer. But as the story evolved, the story became more focused on the general's son, Deke Star Killer, whose name was eventually changed to the famous Luke Skywalker. Well, that's all I got for today, folks. So you have a great day. See you in class. Goodbye.